Yes, sir. We can hear you.
Yeah, sorry for the delay. I got some problem with my connection.
Hello, sir.
So,
Shall we start the program?
will there be any introduction, or are we straight away go into the presentation?
Yes, sir.
A very warm good morning to respected professors, scientists, and all other attendees. It's my pleasure to welcome you all to the technical talk series titled TransTech Talk Series, organized by KSCSTE National Transportation Planning and Research Center. Through this technical talk series, we aim to provide our platform for experts in this field to share the knowledge and expertise with us. Today, the 19th talk series will be delivered by Shri Mohammed Nizar Poovanmadathil on the topic The Path to Greener Seas, the latest trends in maritime decarbonization. Before we begin, I would like to invite Dr. Sabita N.M., Senior Scientist, Water Transport Division, including GIS, to deliver the welcome address.
Thank you, Shama. Good morning, everyone. With great pleasure, I extend a warm welcome to all of you gathered here today for the 19th edition of TransTech Talk Series, organized by Water Transport Division of National Transportation Planning and Research Center, NATPAC. NATPAC, a distinguished institute under the Kerala State Council for State Science, Technology and Environment, is at the forefront of research and consultancy in the traffic and transportation domain. Our mission is to bridge the gap between research and practice, ensuring that innovative solutions are effectively implemented in real-world scenarios. The TransTech Talk series serves as a platform for sharing cutting-edge advancements in the research ideas in the transportation sector. This initiative brings together a diverse audience, including academicians, scientists, government officials, research scholars, and students from across the country who are interested in the transportation domain. Since its launch in February 2023, with an insightful inaugural talk by Professor Srinivas S. Puligurta from the University of North Carolina, Charlotte, the series was featured a range of distinguished experts from both academia and industry. Each session has contributed to the vibrant exchange of knowledge and has deepened our understanding of recent technological advancements in traffic and transportation. Today, we are privileged to have with us Shri Mohammed Nizar Poovanmadathil, Customer Success Manager at Shipshave in Stavanger, Norway, as our speaker to deliver the talk on the path to greener seas, latest trends in maritime decarbonization, a topic of great relevance as we continue to address environmental challenges within maritime industry. On behalf of NATPAC and all present here, I would like to extend a warm welcome to you, sir. And also, I would like to extend thanks for accepting our invitation to deliver this talk. Welcome you, sir. And also, I would like to extend a warm welcome to our director, Dr. Samson Matthew, and all participants present here today. I would also welcome all the staff members of NATPAC who joined here today. And we are looking forward for an enriching session and insightful discussions. After the talk, you are encouraged to post your questions in the chat box or unmute yourself to participate in a meaningful discussion with our expert. Thank you for being here today. And also, I welcome all to the session. Thank you.
Thank you, Dr. Sabita. Now, I would like to invite Mrs. Veena KS, Scientist, Water Transport Division, including GIS, to introduce our esteemed speaker.
Mohammed Nizar Poovanmadathil is a customer success manager at Shipshave in Stavanger, Norway. He is experienced in naval architect with a decade of experience in the maritime industry. Possesses a strong background in ship design and construction, as well as comprehensive knowledge of maritime regulations, project management, and client relationship management. He has earned Master of Science degree in Marine Technology from the Norwegian University of Science and Technology, Norway. He is an associate member of the Royal Institute of Naval Architects. Presently, he is serving as the chair of the Green Shipping Committee at Young Ship International. Over to you, sir. Thank you.
Thank you very much. Thank you for the warm welcome. Let me share the presentation. I will straight away delve into the talk, and then we can speak about all the nuances, and if you have any questions, definitely give me a moment. Are you able to see my screen?
Yes, sir.
Yeah, thank you. So today, we will speak a bit about the decarbonization of the maritime industry. It'll be a comprehensive overview because there are a lot of jargons and new new phrases that you may not be familiar. So I'll not be going into the detail, but I want to touch upon all the important aspects that is going on in the industry. I have been already introduced to you, but it is important that you understand who you are listening to. I'm pretty much available on the LinkedIn. So this is me. I was born and brought up in a place called Kottakkal in Malappuram district of Kerala. I did my bachelor's at Cochin University in naval architecture and shipbuilding. After that, I worked as a ship surveyor, actually. I joined this classification society, or the Japanese ship classification society called Class MK, based out of Tokyo. I joined their Indian branch, and in the initial days, I was involved in the new building surveys. So what we do is we take as the projects and go to the shipyards and do the classification and statutory surveys. That was the initial days. Then I moved to Tokyo. With the hull department, I've been approving ship design plans for a while. And then I returned back to India and have been going to the ports where the ships are called, again for statutory and class surveys, but not during construction, after construction, or during the service period of the ships. Later, I came to Norway for my master's studies. I did a 2-year master's in marine technology, and I specialized in marine hydrodynamics. Then I joined Shipshave, and Shipshave was actually a green technology company in Stavanger, Norway. We have branches in Singapore and Greece. That's a bit about me. Now, I'm going to focus, the first part of the talk a bit about the marine industry itself. Only those topics which are relevant to maritime decarbonization. And of course, in the second part, I will address what are the major trends and what is actually happening in the maritime industry as far as the decarbonization is concerned. But I want to understand you better so that I know how much time I have to spend on the first part or the second part. So it'll be nice if you can go on to slido.com or even scan the QR code on the screen. This is just for me to understand how much you are familiar with the maritime industry. Yeah, I'll wait for 1 more minute. So I can see that most of the audience are not much familiar about the industry. So then I'll take some time to explain that is pretty much unique to the industry, because it is important to understand how the commercial part of the industry works. Then only we will understand, when you read tomorrow some of the regulations or some of the aspects happening in the industry, why it is so. So I'm just closing this poll. I see that majority of the audience are not very much aware of the industry. So let's go through the part one, and I'll try to explain some of the nuances of the industry itself. Yeah. So it is important to mention that over 90% of the global trade by volume happens through water or through the industry, and it is actually the most efficient way of moving the cargo also. So the stake is so high in terms of the trade and economy. Now, another term that is very much interesting in the maritime world is actually the flag of convenience. Now, most of you may have, or some of you may have, a vehicle or a car that is registered at a place where you are residing. For example, if you're in India, definitely you will register it in India. But there's this concept in the shipping industry, which is called the flag of convenience. The ship need not be registered in the country where it is actually owned. So it can be registered in a country, where the owner is not sitting. And you could see that this is the UNC that's, I'll just show you how this has evolved actually. So the number that you see is actually the tonnage, because that is a measure of actually how much cargo can be carried by a ship. Now you see that it's not a lot of the big names that you see where the ships are actually registered. The ships are actually registered today more in Liberia than in Panama and in MI or the Marshall Islands. These are, essentially pretty small countries, and they actually earn a lot, or a significant part of their earnings is actually from the industry, just because of they became the flag of convenience. Now, another thing, if you are not familiar with how many ships are there in the world, this is a satellite picture of all the ships in the water. So you could see, of course, these are exaggerated in terms of scale. So you can see there are inland, inland vessels, but most of them are in the deep sea. And these are, most of them are vessels above 5,000 GT, because they are in the deep sea, and it makes sense to have a bigger ship to carry a lot of cargo for efficiency. Again, for the maritime world, there are a lot of stakeholders. If you see the right side image, you would see there are a lot of people involved in the maritime industry. But it is essential to mention about the ship owner and the charter party and some other players involved in a typical commercial activity. So a ship owner will be an entity who owns the ship itself, but he's not the one who owns the cargo on the ship, or he doesn't, transport the oil or the coal or the rice moving from one place to another. For example, if you want to get oil to India, you can charter a ship. There will be a charter party who are interested in doing this. Or sometimes these charter parties are the cargo owners itself. So it's a very interesting way of doing the business. So you could say that the charter party actually rents the ship for a certain period. Now, chartering activity itself a broad area, and you can charter a ship for a long period, like 5 years, or for a shorter period, or even for a single voyage. So that's how the commercial part of the industry works. So the major charter parties could be, the mining companies or the oil majors, because they have a lot of cargo. And one interesting aspect, what we have to see is this charter party. Traditionally, the agreement between the ship owner and the charter party is like, okay, I'm hiring your ship, and I will also pay for the fuel. It is a bit interesting concept, because when we talk about decarbonization, essentially the carbon factor is coming from the fuel. So it is interesting to see that the party who's paying for the fuel is not actually the ship owner, but it is the charter party. And as I said, it could be a cargo owner, the same as charter party, but again, it can be a different, entity. For example, if India wants to get enough LNG from US, then there will be a cargo owner in the US, and some Indian entity want to get it. So, for example, Petronet LNG, if they want to charter a ship, they will approach ship owner, and they will sign a contract saying that, okay, we will charter a few of your ship for 5 years, because we want this continuous cargo to come in to India. So that's how a typical commercial agreement works. And other than these stakeholders, there's of course shipbuilders, there's banks, there are investors, there are charter parties that I already mentioned, and there is shipping companies who ships the cargoes. Then there are ship managers who actually take care of the ship. It is not the ship owner who takes care of the ship. There are efficient companies who can do that in a much cost efficient and operational efficient way. So what ship owner does is he pays an amount to the ship manager to manage their ship, and also to manage the crew on board that particular ship. So a few things about these stakeholders, but keep in mind that the charter party pays for the fuel. Now the agreement works in such a way that, okay, if you hire my ship and we agree that, okay, at certain weather limits, your ships should cruise, say, 15 knots or 16 knots, and the amount of fuel that you consume is actually within certain limits, say 30 tons per day, 40 tons per day. So that's how the agreement works. If it is beyond that, then the for example, instead of 30 tons, the ship is consuming 35 tons per day, then the ship owner actually can get a claim from the charter party. See, I'm providing more fuel, so it's not something in our agreement, so you have to do something about it. So once we understand this one, then another aspect of the industry is the regulatory compliance itself. It is easy to say that the industry is highly compliance driven. Again, the industry or the ship owners are sitting for business. They are not sitting for the charity, unless and until someone comes with some regulations or rules. Nobody's going to, agree and take into consideration. So that's where the regulations came in place, and the major regulations I would say today, that had an effect until now is actually SOLAS and MARPOL. These are, of course, frameworks from IMO. SOLAS means safety of life at sea, and MARPOL is actually a convention or maritime pollution prevention convention. Now, what all regulations can come in? The major one is, of course, from IMO. IMO is actually the United Nations, the regulatory body, and it is formed by the member states. It has 195 member states, and they discuss about what should happen in the international waters. They meet every now and then. It is actually a huge, the major part of the industry, I would say. Then there is, of course, EU. Certain we can call them, regional. We can call it regional regulations, and there are, of course, ports, and there could be local regulations. For example, if you think about Kerala, there is this Kerala Inland Vessel Rule 2010. I think it was in discussion a lot after the Thekari boat incident. So the industry is driven by this compliance. That's what we need to. That is a major takeaway from this slide, I would say. Okay. Now, having these things in mind, I will delve into the decarbonization of the industry itself. It actually started in, this is not only for the marine industry or the maritime industry. In 1997, the Kyoto Protocol, some of you may already aware, Kyoto Protocol discussed, the decarbonization of, that was mainly focusing on the developed nations. But when it came to 2015 with the Paris Agreement, there are a lot of attention. I believe that was COP21. And under UNFCCC, this is a convention on climate change from United Nations. And to combat climate change and reduce the greenhouse gas emissions, the major point from that Paris Agreement is, okay, we should limit the increase in the temperature every year within 2 degrees. And we should strive to limit below 1.5 degrees. Now, today with this treaty, there are 194 parties, and essentially European Union has a lot of countries, so 193 plus European Union. That is part of the Paris Agreement, meaning everyone in this world is agreeing, okay, we need to decarbonize. And what is the effect actually? What is the effect of this climate change? This is an interesting report from World Meteorological Organization, and you could see what is the hazard it has cost, right? And when we speak, and we know that how much we are devastated by the floods and the landslide, the landslide that happened in the Wayanad, and essentially it has some effect from the climate change. And the economic losses from the period of 1970 to 2021, they calculated it will be approximately USD of 4.3 trillion. And more importantly, there was a 2 million deaths also. And you could see the major, from the period, in a 10-year period, what was the major problems? Initially, it was storm, but lately you could see that it is extreme temperature. From the period 2010 to 2019, the major issue is the extreme temperatures. And last summer, or for the last few summers, we have been experiencing it, right? Even where I stay here, we are seeing record temperatures. I think this time Oslo hit 30 degrees, and even France or Paris hit close to 40 degrees. So that is the alarming level of temperature or extreme temperature we are seeing. So this is the main, I would say, agreement or treaty where we all agreed, all the nations agreed, okay, we want to strive to keep the limit, or we want to limit the increase in the temperature. Now, what is the stake of the industry? We talked about, okay, there are a lot of ships in the water. Now, how much are we emitting? Roughly, we are emitting close to 3% of the total emissions, total greenhouse gas emissions in the world. And this 3% is almost equal to, the CO2 emissions of Germany, or somewhat equal to how much the Japan as a country is emitting. And Germany is, of course, a developed country with more than 80 million population. So definitely, we also need to strive reduce the carbon footprint. Or today, it's more of GHG footprint. Why we say decarbonization is because 95% of the emissions of the industry is from CO2. That's why you will see most of the terms is pictured or mentioned as CO2 emissions instead of the general framework of GHG. Even though there are like methane, I think methane is potent around 25 times of CO2. So if you have 25 tons of CO2, and if you have 1 ton of methane over a period of 100 years, the impact is the same. So that 5% actually comes from other gases, GHG gases, and the 95% is, of course, CO2. So what we are trying to do is reduce this one. And if you, in the industry, if you keep it like this, it can actually increase by 85%. If you say by 2050, how much how much emissions can be increased? For example, if there is 1 gigaton is emitting this year, then by 2050, the shipping industry will be emitting 1.85 gigaton. So given the scenario, it is very important that we decarbonize the industry, or we put efforts to do that. Now, how are we doing that? Today, where are we? The key initiatives and the regulations, I would say it happened in 2023. This significant development happened actually from IMO itself, because as I mentioned, if we don't bring an international regulation, nobody is going to agree, because every stakeholders has their economic interest. So 2023 at an MEPC, this is Marine Environmental Protection Committee of the IMO, at their 18th meeting, they came up with a revised strategy, because in 2018, MEPC agreed that, okay, we will cut the emissions of the industry by 2050, or we strive to do that by 2050, 50% of how much we are emitting in 2008. But in 2023, like that is just 5 years from 2018, they revised the strategy. They said that, okay, instead of 50%, we are striving to completely decarbonize the industry by 2050. So one is that regulation itself, and there is new legislation. We'll talk about it more in the coming slides. Now, every company, every cargo owner, every stakeholders, like if you're a cargo owner, if you're a company associated with the industry, like if you want to ship your product, then you will be also in question, because every company has this ESG, right? You might be heard of it previously, environmental, social governance. So they are getting questions. Okay, what is their footprint? Are they using more eco-friendly channels, or are they partnering with more eco-friendly partners to ship their products? So everyone, whether it is cargo owner, financial institutions, and even you can imagine the shipyards, they're also a major one. They should have enough capability to provide a eco-friendly ship. So because of there's a pressure, if you use a dirty ship, if you use a dirty fuel, you will be limited by your economic activity. Your ship will not be hired. So what happened because of this is there were net zero offerings also, since this ESG stakeholders were looking for more ESG compliance. Part of the industry were also working for that, and there is a demand for it. So there is a net zero offerings. So together, I would say that there is the regulatory framework, and there is a demand from these companies, and the offerings, the new technologies. These together are the initiatives that actually going to decarbonize the industry, or at least today, that is the one. The key initiatives that will decarbonize the industry. Now, I mentioned about the IMO strategy. It is a bit important to understand what is the framework, because this has stirred up the industry, and nobody, every one of them, industry has to work for this one. Otherwise, you will get penalized. Penalized in different ways. That is also coming next. So since IMO is the regulatory framework for the international waters, they are looking at it today, and they mentioned that, okay, we keep the 2008 as the base year. We want to reduce the emissions to zero by 2050. And as you see, in 2018, what we agreed was, okay, we will strive to decrease it to actually the 50%, not 100%. Now, in 2023 only, you will see the green line, depending on, what is the base emissions of 2008. We want to have a, transition to that phase. Or today, there will be a transition phases. So by 2030, what we are aiming is actually for a 20% reduction in the total GHG gases. And this is about, from a well to wake concept. I'm coming to that. What is the well to wake? And also strive to reduce the intensity of the reduction. That is the CO2 emitted per transport work. So they also have some how they are going to penalize the ships if they, if the footprint is too much. For example, if I want to move 1 ton of cargo from A to B, you do that in the most efficient way. So even though, every year you emit only less, but depending on how much cargo you have moved, your intensity has to be reduced. And again, by 2030, 5% of the fuel or the energy share has to come from zero emission fuels, or e-fuel, you could say. And by 2040, it has to be 70%. And that's actually too much. Why is that? Because we are sitting in 2024, and a ship owner, typically a ship can, will have a life of 20 to 25 years. And if I am a ship owner and I want to construct a new ship, he has to deal with, the 70% reduction target within, say, from 2024 to 2040. It is actually within 15 years, actually. So that's a huge challenge, because today, if you see, we don't have so much of technologies that will give you 70% of the reduction. So that's why a lot of transformation is happening in the industry. Now, one more thing that I mentioned, actually, if you, at the current levels, if you don't do any of these activities, the emission is going to increase. That is what the blue line indicates. And you could see the emission gap from what it will be if we don't do anything versus what we are striving for in 2050. So I hope you got some idea of this strategy. Then another thing that I would mention, okay, how this transition can happen. What can we do in terms of on a ship to avoid this GHG emissions or reduce the carbon footprint? So this is something the IMO has even came up with, because IMO also has sponsored projects to study about what is the effect. And you could see that, from the power and propulsion systems, we could save 5 to 15%, or the impact or the reduction can be as much as 15%. And if you do a bit of fleet management, logistic, and the incentives, you can go up to 50% of the reduction. And there is, concept speed and capability. It's a bit of technical. For example, if you move a ship with a speed of, say, 10 knots, say at a speed of V, the power required increases at the cube of the speed. So if the increase in the speed, for example, if you're moving the ship at 12 knots, and if you reduce it to 10 knots, so the difference in the power required is actually 12 cube minus 10 cube. That will be the factor. So each increase in the speed is actually causing leading to an increase in the power. Now, what happens is when you increase the power, there will be a lot of footprint. You need a lot of fuel to spend to move. So what we can do is immediately is, okay, if you're going a ship at 12, let me reduce it to 10 knots. Can I survive? That's what everyone was trying to do in the past few years. Can I derate the engine? Can I go slower? Then my footprint will be less. Again, I also, reduce my fuel requirement. One of the project where I work today is actually regarding the biofouling. This is actually when the moment the ship is taken into the water, it will get fouled because of it starts with a microfouling with the microorganisms, and along the journey, because the ships are normally dry docked in a period of 5 years in the early stages, and after 10 years, it is dry docked in a 2.5-year period. So ships are, we are built for not to keep it at the bay, but to put it in the water, right? To move the cargoes. So if you move it in the waters, there'll be a lot of fouling happening, and that's where we work today. And typically, if you remember the agreement that I mentioned between the ship owner and the charterer, okay, there is some question. I'll take it towards the end. Yeah. So the one Okay. Sorry. So one of the area where I work is actually the biofouling management. So where I stopped is, the fouling is getting on the side of the ship. So you need to clean the hull. So if you don't achieve the speed, if you're a ship owner, if you don't achieve the speed by certain fuels, for example, by burning 30 metric ton of the fuel, then you will get claims from the charter party. So you need to clean the hull. And what typically a ship owner do is he will wait to get the claim. So for example, he'll wait for the 2 years, but essentially he'll be burning more fuels. So what we have worked on as Shipshave is actually introducing a robot that can be used by the crew itself. They don't have to wait for the divers or the ROVs. The crew can clean the vertical sides of the hull. So then they can, improve the efficiency by 5 to 25%. Now, the frameworks I mentioned about the IMO, the framework. Now, apart from IMO, there's also the EU legislation, and I mentioned about the financial institutions also has some interest, and that is the Poseidon, or sometimes called Poisson principles. And again, one more framework is by the sea cargo charterers, because they're essentially chartering the ships. So they're also coming, or they're also coming with their own framework, to check the decarbonization or the carbon footprint in the industry. Now, I will just touch upon some of the frameworks that's adopted by IMO and then by EU and other entities. So it started actually between 2013 and 14 with EEDI. EEDI is actually an index for a particular ship, that is for a new building ship, not the one that is already in service. So in 2013-14, they came up with this EEDI, and they said that, okay, you have a calculation you have to do, and your ship should have an efficiency at the design stage itself, so that it will emit less in the, during her service. And along with it actually came a SEEM. SEEM is actually a energy efficiency management plan. And when EDI was introduced, there was part one. Part one will tell you about, what in general, what you can do to reduce the footprint, or how to achieve a better energy efficiency. And when it came to in 2018, there was part one and part two. There's a reporting came in. That's what the second part of the SEEM will address. And now you have part three also, where the CII, one that you could see the measures for or what is your 3-year plan for achieving CII? That will mention the part three of this manual. Now, how these things, to make the decisions, IMO came up with this DCS system, that is data connection system. So in 2018, every ship has to report their emissions. What fuel are you burning? How much are you burning on an annual basis? So that's where the reporting came in. So now IMO has a database for all the emissions from the ships. And then came, since the EEDI was introduced in 2013-14, now how about the existing ships? There are a lot of, because the major chunk will be the existing ships, right? The ships that is already built and in service. So to, give a metric for them, give an index for them, what you should do on a ship, such a ship, that is, done a similar calculation like EEDI for EEXI. And similarly for CII, there is also a tag. You will get a ranking of A, B, C, D based on a calculation. And you should, for example, if you're emitting today, say so much of amount of CO2, in next 2 years, if you don't emit or if you don't reduce the emissions, you will automatically degrade it. You will get a degradation from, say, if you're in the C, you'll be degraded to B. And you have to come up with a plan how you're going to improve that, or how you're going to, go from C to B back. Similarly, in progress is the carbon pricing. Again, there's a GHG fuel standard is also discussed at the IMO. Then another one important, regional legislative body is EU. They have actually their own legislations, and it is a talk in the industry. The EU actually runs a bit forward, or they are much ahead of IMO, because IMO has to take care of all the member states. EU typically has a lot of developed nations, so they move ahead a bit. Very much similar to DCS, you have the MRV framework that also collecting the data. Based on the data, now today the EU ETS framework, the emission trading system, has been established. What you will be given, each ship will be given. If you're calling to EU, then you're under this EU ETS or EU framework. If you're not, if you don't have any trading in the EU, of course, you are not. You don't have to address any of the EU legislation. But the trick is, if you're moving from, say, your ship is going from Singapore to, say, France, then 50% of the emissions is considered for the EU ETS. But if you're moving your ship from within the EU, say from France to Spain, then the 100% of the emissions are considered for this EU ETS. It is essentially an allowances. Today, I think it stands at $60, one allowance. So there's a trading system. So if you emit more, everybody has to buy these allowances from the how we do it in the share market. It will go up. So that's a pricing mechanism, and it's actually a trading mechanism. And the next one is an important one I would mention is the fuel EU maritime. So there are alternate fuels instead of the HFO, which is a dirty, emitting, which has higher footprints. We want to go to less footprint fuel. How are we going to do that? So the framework has been set by Fuel EU Maritime. And in that framework, what we does is, okay, how can we, penalize more dirty fuels, and how can we, incentivize who uses a e-fuel? That is the concept. Now, ETD is again in progress. Similarly, Poisson principles, this is put forward by the financial institutions. All the banks, I think the 25 to 30 banks came together and said that, okay, we will also have a framework. We will look into to whom we lend the money. If you are more greener, then we want to work with them. Then in their portfolio, because if I'm a bank, I'm lending to one ship owner for their operational activities, then his carbon footprint will be again on them, right? Because of the ESG. So instead of that, they are also going to check, who they are working with. So it again will force us, the ship owner or any entity involved in the maritime industry, to reduce their carbon footprint. Similarly, sea cargo charters, the charter team, they are also not ship owners. So they came together and they said, okay, we will also have a very similar framework. They came up with EEOI because they are concerned about this operational index. It is much similar to other framework we mentioned, but more of from a voyage to voyage scenario. This is a short format of the frameworks and the standards currently, which are most important ones. And also, it is important to mention a bit about the alternative fuels. If you see the new buildings and you see that the number of orders, this is the new building orders. And of course, before 2024, we know what is delivered. And you could see that in 2024, there is an order book of 199. And in 2028, you could see that, by 2026 and 2027, there is already a lot of increase in the methanol. And one of the reasons is actually, Maersk came up, started with one ship that can use an e-methanol on their ship, and they kind of set a standard. Okay, we will be, starting with methanol and see how it goes. So definitely other ship owners or entities also wanted to, go with one side. More interestingly, I think day for yesterday, Hogue Autoliners, another major PCTC or the pure car carriers, they delivered one ship that can use ammonia as their fuel. And on the other side, in service or the alternative fuel ship trend, you could see that the LNG has been increasing considerably. And other side, the methanol is also increasing, and there is a demand for LPG, but most of them are still fossil fuels, and it's not only enough, just to get the ammonia. We also wanted to know how that ammonia is produced, because if it is not ammonia, if again the ammonia is processed with the help of fossil fuels, it is not completely away from the footprint, right? Carbon footprint. So that's how the new alternative or the fuel trend look like. Yeah. Now this one, life cycle assessment. Actually, IMO came up with at MEPC 81 that happened a few months back, and came up with this concept called well to wake. So till now, what has been happening, or the major calculation were happening, when the fuel is arrived on the ship and how much it is burned. So you could see that from the tank to wake concept, that was the major one. And because of the alternative fuels in picture, you will come up with a lot of fuels. And one example that sometimes people quote is, okay, I have an electric car here, but if I charge that electric car with an oil generator, then that doesn't make sense, right? So similarly, we don't want to move that footprint from the industry to another industry. We want to consider the overall, what is the footprint from its life cycle. That is mainly about the life cycle assessment. This has the guidelines have just came. This will be taken care, I think, in 2025. Yeah, next year this will coming into picture. Yeah, so I'm trying to conclude. So mainly what a ship owner or any entity involving in the maritime industry, they have to reduce the energy consumption now. They have to consider all the decarbonizing options, and they have to focus on fuel flexibility today, because if you have a flexibility of using, e-fuels, for example, if I can run my ship both on ammonia and HFO, that is good, right? Because wherever it is available, I can use ammonia. If it is not available, then I can switch back to HFO. Now, we also need to have a long-term strategy. There is a lot of challenges, what ship to build, what technology to go for. So if you have a long-term fuel strategy, then definitely that will help all. Yeah, now I'm open to questions. I saw that there was one question while I was explaining. So please speak up. Yeah, okay. I saw this message in the chat from Sanjay. Please throw some lights on the change in the emission levels with the speed change. Yeah. So, if you see the power curve, the power required to move the ship versus speed. And typically, when we talk about the speed, all these ships are, cruising at the range of say 10 knots to say 22 knots. If you are a bulker, you typically cruise with say 12 knots. If you're a container or if you're an LNG, you will cruise at 18 or 22 knots. So again, it is driven by the economics. But if you increase the speed, since the power required is a function of VQ, if you assume the speed is V, then it is directly proportional to the cube of the speed. So you can assume when you increase the speed from 10 knots to 12 knots, the power required will be that much of difference. It's not linear, right? It's a cubic curve. So instead of, I mentioned about the EXI, right? In the industry, what happened is when the EXI was introduced, immediately what every ship owner did was they derated their engine so that, okay, if I'm going to use it, my trade is mostly at 10 knots or 12 knots. Why should I have an engine that is rated for 15 knots or 14 knots? Because that is the maximum the engine can, safely go. So they immediately went into stock and derated. And some of them even changed their design. For example, the bulbous bow, because the wave resistance is actually can be reduced by having a better bow. So what they did was, okay, if I'm not going to cruise at 18 knots, but if I know that I'll be cruising at 16 or 15, let me change the design of the forward of my ship such that it is more efficient at 16 knots. Did that answer your question, Sanjay?
Yeah, Nizar, this is Samson, director. Yes.
Yeah.
And I have, continuing to that one, see, the speed, probably that will be something connected with the profit which you are, the economy is also included in that one, no?
Yes.
Because,
Yes.
Yeah.
Yeah.
So the balance that speed and the fuel efficiency.
Yeah. There are a lot of factors even other than the economy that is affecting. It's easy to mention about the economy because that is driving, right? We mentioned about the charter party agreement. Like, okay, I have my ship. For example, I am a ship owner and you are a charterer and you are hiring my ship. So I have an efficient ship and you decide at what speed the ship to go. And because you are providing the fuel. So that's where the economy is driving. If I want this, since our agreement is, okay, my ship will burn 30 metric ton at say 12 knots per day. And you would say that, okay, no, please increase because you have a capacity to increase up to 14 knots. Let's go in 14 knots. But that is where the trick is coming in. That change in the 2% can actually increase the power requirement, fuel requirement. And the trick is, okay, I'm going to pay the fuel, but you are going to make the footprint on your ship. For example, that footprint, part of the footprint will come on me because I'm burning more fuel as per your suggestion, right? You want the cargo to move faster. So that is one framework, but this is about economy. Now there's another aspect what I wanted to mention. You might have heard of the Red Sea event. Every ships that is going through the Red Sea has been targeted by the Houthis because of the war scenario. So many of the ship owners has been forced to go around the Africa, the Cape of Good Hope. So that much of distance the ship has to cover in such a short time. Because if they don't cover the time, they are not efficient. So instead of they have been moving at 15 knots, today they are forced to move at 17 knots. So it's not only, of course, economy is a driving factor, but again, there are other factors also happening, and most of them because of the political interest.
Yeah, thank you, Nizar. I have one more question. Now that the hydrogen as a fuel technology is it is an increasing trend, probably even in Kerala also. Now that we are promoting that one, can you throw some your experience in that because hydrogen is it's a good fuel which can be used as an alternate, especially for ship.
Yeah.
Yeah.
One thing just wanted to clarify is actually, everything what I mentioned here is about the major chunk of the industry. Now, how we filtered it out is actually, any ship uh, that has more than 5,000 GT. We talked about any ship that is more than 5,000 GT. So we have not essentially included all those inland small vessels because they're pretty small and the footprint is also small. But coming to your question, uh, one of the challenges actually, everyone knows this hydrogen embrittlement. And the other one, say that if I have a ship of so much of tank capacity, say, you could see that the ship is designed in such a way that the maximum volume can be used by the cargo, right? Now, in the traditional ship design, say that I have 1,000, unit of volume, and in which, say, the 5% or the 10% of the volume is occupied by the fuel oil tanks. If I just change to hydrogen, that requirement, the volume I need on the ship, it goes to 2.6 times. So it's not only about, getting a fuel, but as a ship owner, I have to compromise my space of the cargo also. And another thing, definitely that is directly, uh, directly important is, how much we are ready to use hydrogen. Is it really safe? Are the seafarers really trained for that? So all those are definitely, if you have in the ideal situation and, the fuel to get it, the chicken and egg problem, very similar to what we have for the electric cars. If you don't have enough charging points, we are not going to buy the cars. We will have the range anxiety, right? So similar to that, there are different levels of problems that the industry facing. So I would also mention that it is the best time to be in the industry because of so much of challenges, because there are so much of opportunities also.
Thank you, Nizar. Others can interact.
Good afternoon. Myself, Dr. Emisha. I'm a junior scientist in Water Transport Division in NATPAC. First of all, it's a very informative talk. And I have a doubt regarding the transition of a conventional ship to an eco-friendly ship. Maybe that may be like fully electric or bio-LNG or LPG or hydrogen fuel. So we have two options. We can convert a conventional ship to a new eco-friendly ship, or we can construct a new eco-friendly ship. So when we are converting, is there any change, any effect on its structural or functional efficiency of a ship, and for a ship owner, which will be beneficial?
Yeah, it's actually a very good question, Ramisha, because I also had this question back in 2019 or 20, and let me go to that particular. Did I move away? Yeah. So if I understand the question well, as okay, as a ship owner, should I buy a new ship or let me retrofit or let me strive to, having a lot of things on the existing ship? I thought that initially, okay, that made logical to me. Let me do all sort of these, I would say circus, because one of the seafarer I met, when I was traveling to India from Norway, he was in his 60s, and he said, okay, see, a lot of circus is happening in the industry, and we have to suffer as a seafarer. So that's why the word came circus. The point I'm making is, what I understood when I spoke with some of the experts or even some of the conferences is, it is better for a ship owner to build a new ship. As far as the carbon footprint, as far as the efficiency, because what I thought is when you build a new ship, there is enough footprint. You need to get, these ships are essentially built from the structural steel. You need to roll the steel, right? You have a lot of footprint for all those items coming in. So what we understood is, if you have a ship that is, say that is 10-year-old, it is more efficient to get a new ship as far as the decarbonization or the footprint is concerned. But what he's actually doing, you can't do that, right? Because he cannot because of the economic activity. Say that if I'm a ship owner, I'm already in, in an agreement with the charter party for the next 3 years or 5 years. I've already signed it, so I have to, I have to, comply with that one. Now, what every one of them is doing is actually, can we retrofit, certain items on the ship, so that the footprint is reduced. One method I already mentioned that was there in the industry when the EEXI came in as reducing the reducing the speed, derating the engine, and even making the bow modification. That was the major one. Another one, what I can remember is, there was a catalytic reduction scrubber was used, but that was mainly for the, if I remember correctly, that was again to comply with the sulfur cap, because when the HFO and the MDO, which are the primary fuels that has been used in industry, this has a lot of carbon footprint. The next step came into the industry was VLSFO, which is very low sulfur fuel oil. In order to reduce that, say that, okay, if I have a fuel oil that has 3.5%, then the sulfur cap says, okay, you should get a fuel that is less than 0.5%, or you should not emit. Ultimately, you should not emit any sulfur oxides into the air. Yeah. So this is the overall picture. Did I answer?
Yes, sure. Thank you.
Yeah. Yeah. So if there are no more questions, I would say thank you so much for inviting me. In fact, I also learned something when I referred some of the aspects about the commercial part of the industry while I was making this presentation. Thank you.
What I would like to ask is that you are telling about the legislation that is done by the IMO, right? So is it like entirely for the the total shipping industry IMO is holding these things, or there are local legislations being made by the countries, or it's only or it has, or how it is monitored, as you have shown in the satellite image that industry is so vast. So how these legislation monitoring and all these things are happening?
Yeah. I don't know if you remember, I worked as a ship surveyor previously. So I was part of this RO, we call it recognized organization. So how it happens in the industry is all the international rules, the statutory rules that is imposed. Every ship is registered with a flag, right? It could be India, it could be Panama. So if you will have a certificate, okay, I'm registered in so and so country, then you have to abide the rules set by that country in terms of in terms of okay what they have agreed. The point I'm making is the rule, when it comes to the ports, of course, there is PSC to check. For example, if an Indian ship is called onto Indian territory, an Indian PSC can check. But more importantly, these compliance are checked by ROs. For all these flags, there are ROs, and the ROs are mainly classification societies. They are one of the major stakeholder in the industry. They make rules. They check the compliance. That's what I was doing previously. I go onto the ship, I check if everything is as per the as per the rules, and I give advices, and I also sign if everything is compliant. But I'm not actually an inspector, DG inspector and the PSC inspector. I was not doing that. So it is actually all these frameworks are checked by mainly ship surveyors, classification society surveyors, and then there is, of course, for every port and DGs, they have their own inspectors.
Thank you.
Thank you, sir. That was actually a fantastic technical talk on the path to greener seas, latest trends in maritime decarbonization. Now, I would like to invite Dr. Remisha, Junior Scientist, Water Transport Division, including GIS, to deliver the vote of thanks for today's section.
Good afternoon. We have been privileged to gain deep insights into the topic, the path to greener seas, latest trends in maritime decarbonization, delivered by our distinguished speaker, Shri Mohammed Nizar Poovanmadathil. Your expertise has not only enhanced our understanding, but also have motivated us to look into distinctive characteristics of maritime sector and the strategies employed by ships to mitigate their environmental footprint. We truly appreciate the time and effort you put for preparing and delivering such an engaging talk. The inclusion of case studies and interactive discussions has enriched our learning experience and provided us with valuable insight. We would also like to extend our thanks to all the attendees for your active participation. Your engagement made this event even more valuable and created an atmosphere of collaborative learning. We hope that you found the information presented today both informative and inspiring. We are very much thankful to our director, Professor Samson Matthew sir, for his constant guidance and support in shaping this wonderful event. As we depart, let us carry forward the knowledge gained and the connection made. May the insight shared today fuel our curiosity and drive for excellence in the field of transportation. Once again, I would like to express our sincere thanks to Shri Mohammed Nizar, the NATPAC team, and all of you for making this technical talk a great success. We look forward to much more enlightening sessions in the future. Thank you and have a wonderful day.
Thank you,
Thank you.
Nizar.
Yeah, thank you so much. Bye.